Chapter 1, Test Review. Jake is a car buff who wants to find out more about the vehicles that students at his school drive. He gets permission to go to the student parking lot and record some data. Later, he does some research about each model of car on the internet. Finally, Jake makes a spreadsheet that includes each car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a navigation system. What variables did Jake measure, and identify each as categorical or quantitative? So the different variables that were measured, the first one that he measured was the car's model. You can't find the average model of a car. It's just going to put it in a specific category, so that is categorical. The next one would be the year. And we can find the average year of a car, so year would be quantitative. We would look at the color of the car. The color is just going to put it in a specific category, so that would be categorical. The number of cylinders the car has, you could find the average number of cylinders, so since you can do a calculation with it, it is quantitative. The gas mileage a car gets would also be quantitative. The weight of the car would be quantitative, and whether it has a navigation system or not would put it into a specific category, so that would be a categorical variable. The radio audience rating service places the country's 13,838 radio stations into categories that describe the kind of program they broadcast. Based on the pie chart, what can you conclude? So there are many different answers you can come up with this. It's just looking at the graph, make a conclusion based on what you see. So one possible answer are there are more country music stations than contemporary hit stations in the United States. How many pairs of shoes does a typical teenager have? To find out, a group of AP Statistics students conducted a survey. They selected a random sample of 20 female students. The following is the number of pairs of shoes that each respondent reported having. Here are the data. Find the third quartile of the number of pairs of shoes in the distribution. So since we know we have 20 respondents, or 20 pieces of data, the median is located between the 10th and the 11th data point. So if we count over, the 10th data point is 26, the 11th data point is also 26, so we know we have a median of 26 pairs of shoes. To find the third quartile, we then find the middle of the second half of the data. There are 10 pieces of data to the right of the median, so we need to find the value between the 5th and 6th data point. So if we count over, we need to find the value between the 5th and 6th. Our 5th value is 38. Our 6th value is 49. If we add those two together, we're going to get 87, and we divide that by 2, we're going to get 43.5 as your Q3. People say that it takes a long time to get to work in New York State due to the heavy traffic near big cities. What do the data say? Here are the travel times in minutes of 20 randomly chosen New York workers. Find the median travel time of the New Yorkers traveling to work. So to find the median, the first thing that has to be done is you have to put the data values in order from smallest to largest. Since we know that there are 20 people who are in the sample, the median will be located between the 10th and the 11th observation. So if we count over, we know that 20 is our 10th observation, 25 is our 11th observation. So we need to find the average of those two data values. And 45 divided by 2 gives us 22.5 minutes as the median amount of time a New Yorker travels to get to work. The histogram below tells us about the percent of foreign-born residents in each state and the District of Columbia in the United States. The percent of states with less than 15% foreign-born residents is close to what? So less than 15% would include this bar, and this bar. Now we know we're talking about the United States, all the states, and the District of Columbia. So we know we have a total of 51 observations. We have around 20 observations for up to 5. We have about 13 observations for up to 10. And we have 10 observations for up to 15. If we add those together, we're going to get around 80%. Which of the following statements about this distribution is not correct? The histogram is skewed to the right. The median is less than 10. The mean is greater than the median. The histogram is unimodal, or the IQR is 10. So if we take a look, we can definitely see that this histogram is skewed to the right. The median value would be the 26th value. We have 20 values here. We have 13 values here. So the 26th value would be somewhere in this bar. It's definitely less than 10. Because the data is skewed to the right, we know the mean will be farther to the right than the median. So we do know the mean is greater than the median. We do only have one peak on this, so it is unimodal. But because we do not know the specific data values, we cannot determine the IQR. In 1912, the luxury liner Titanic, on its first voyage across the Atlantic, struck an iceberg and sank. Some passengers got off the boat in lifeboats, but many died. The two-way table below gives information about the adult passengers who lived and who died by class of travel. Create a totals row and totals column to fill in the row and column totals in the margin of the table. So if we add a total, we know the total number of first class passengers is 319. The total number of second class passengers is 261. And the number of third class passengers is 627, which altogether means there was 1,207 passengers on the Titanic. If we total the number of passengers who survived, you will get 442. And if you add up all the passengers who died, you would get 765. Now we need to compute in percents the conditional distributions of survival status for each class of travel. So for each class, we're going to have to break this down. So in first class, you have how many survived and how many died. In the second class passengers, you have how many survived and how many died. And in the third class passengers, how many survived and how many died. Now we are still going to need those totals. So if we look at just the first class passengers, out of the 319 first class passengers, 197 survived, while 122 died. So that means approximately 61.8% of the first class passengers survived, while only 38.2% of the first class passengers died. On the second class passengers, we had 261 total for second class passengers. 94 of them died and 167 died, which tells us that 36% survived, while 64 did not survive the Titanic. And of the 627 third class passengers, 151 survived, while 476 did not, which tells us that 24.1% survived and 75.9% did not. We need to display the conditional distributions in a graph, and don't forget to label the graph completely. So if we go back to this table so we can see all our information, when you go to graph this, you would need to label that we're going to have first class passengers, second class passengers, and third class passengers, and this is talking about the class. And then we can look at the percent. Now, we can color code this and say the red are the ones who survived, and green are the ones who died. So if we look at the first class passengers, we said that 61.8% survived, while 38.2% died. We are looking at different categories, so this should be a bar graph. On the second class passengers, 36% survived, while 64% died. And third class passengers, only 24% survived, while 75.9% died. Make sure when you make this that you label all the axes appropriately, you give a scale, and you give a key to what your graph is describing. What percent of all first class passengers survived the Titanic? So if we go back and look at our table, we can easily see that of just the first class passengers, 61.8% survived the Titanic. Which of the following conclusions seems to be supported by the data? A higher percent of third class passengers survived than first class passengers died. The survival rate of the second class and third class passengers combined is better than the survival rate of the first class passengers. Or a lower percent of third class passengers survived than the second class passengers. So if we go back and look at the table, it's very easy to see that a much lower percent of third class passengers survived than second class passengers. Draw a histogram of the word length data provided below. So if we draw a histogram, we're going to call this length. So we can go from 0 to 1, 1 to 2, 3, and so on. You need to try to make sure those class widths are the same. And then we can do the count. And we need to go up to 25. So From 1 to 2, we only have 1. From 2 to 3, we have 15. Remember, on histograms, they need to touch. 3 to 4, we have 25. 4 to 5, we have 7. 5 to 6, we have 5. 6 to 7, we have 7. Then we have 8, back to 7, 7, 6, 8, 3, and then back to 1. Use the same scale to draw box plots for the travel time for the workers in North Carolina and New York. Remember, to be able to do this, you can use your calculator. You would go in, you would put list 1 into your calculator, put list 2 into your calculator. You can turn on your plots by hitting second y equals. Turn plot 1 on, make it a box plot. Turn on plot 2, make it for list 2, also make that a box plot. If you hit zoom and then select number 9, which is zoom stat, it will be able to plot both box plots beside each other. If we need to write a few sentences to compare them, if you have graphed these onto your calculator, you can see that both distributions are skewed to the right. The variable for travel time for New Yorkers is 27.5 minutes, which is more than for a North Carolina worker, which is 20 minutes, based on the IQR. The median travel time for New Yorkers is slightly longer than North Carolinians at 22.5 minutes versus 20 minutes. You've been asked to report on the different travel times for your school newspaper. Write a few sentences to describe the differences between travel times to work for North Carolinians and New Yorkers. So if we had to describe this, we could say, when considering where to live, people may take into account travel time to work. People who live in New York have a higher variability among their middle 50% of travel times than North Carolinians, at an IQR of 27.5 minutes versus 20 minutes. The median travel time for New Yorkers is also higher at 22.5 minutes versus the typical 20 minutes of a worker would take to travel to get to work